to to your presentation, that we're looking to hear your thoughts how we can move forward with cloud orchestration for the hybrid cloud architecture. So over to you.
Thank you, Seun. My name is Iyiola. I'm here to present my cloud orchestration for the hybrid cloud architecture. So how leading practice has helped me to integrate existing Azure and AWS cloud architecture is by the leading practice industry standard has helped me to explore new ideas and reflect practical market requirements that AWS and Azure offers and how I can apply them. So the complication I saw, the gaps in coming up with this resolution is actually my solution is using SAP S/4HANA on Azure and AWS for large instances that includes high reliability and disaster recovery, and how NFS storage is used for large instances of SAP HANA. Actually, SAP means System Application and Product, and is the market leader in enterprise application software and one of the world's largest independent software manufacturers. SAP enables companies to use live data, predict customer feedback, streamline processes, and connect their entire business. So some of the gaps I noticed, Azure machines are grouped into cloud service and respond to the same domain name with various ports, whereas the AWS machine can be accessed separately. This has actually made some AWS cloud platform services like Amazon S3 has been hacked recently, and as some information has been leaked. Azure has virtual network cloud, whereas AWS has virtual private cloud. So these are some differences I noticed, but the gap is just the various ports where AWS machine can be accessed separately, which made this Amazon S3 liable for hacking if it's not properly set for security. For resolution, this SAP S/4HANA solution architecture, it illustrates how a user request flow through an SAP landscape built on high performance Azure virtual machine and an in-memory HANA database running on HANA large instances for unparalleled scalability and performance. So basically, the system has taken advantage of OS clustering for database, and it has high availability using HANA system application and a full disaster recovery. So using leading practice objects-oriented modeling, I've been able to analyze, I've been able to categorize, I've been able to decompose and compose the cloud platform services that is being used by AWS and Azure. So this is how I started my decomposition of AWS and Azure platform. So these are the class type level 1 for AWS and Azure level 1 on platform services. So on Azure level 2, it's SAP HANA on Azure on VM and SAP HANA on Azure on WS. I've been able to break them down. I'm going to go into E+ after my presentation so I can explain how I've been able to do this, the composition of the cloud services on both Azure and AWS. So I was able to categorize them in different subtypes, I decompose them into level 1, level 2, and level 3, and level 4, and the work they do. So still, this is also the Azure level 3 and AWS level 4. Then finally the previous one was level 3, and now this is the level 4, which is the subtype. So this is Azure Cloud Orchestration. So permit me to go into E+ now to explain how I come about this. So this is my first model, which is my SAP S/4HANA for large instances on Azure. So for on-premises, and if I come into the object, so my class type level 1, which is the Azure Platform Service, and SAP HANA on VM, which is the level 2, then the on-premises SAP user, which is used to execute a sales order via Fury interface and custom interface on order. So I'm going to go into where I actually compare the two, Azure and AWS, the work they do. So NAT Gateway performs the same job that on-premises SAP user does on Azure. NAT Gateway is being used on AWS, but on-premises SAP user is does the same job that NAT Gateway does. When it comes to front-end express routes, on Azure, front-end express routes does the same function that Amazon Direct Connect does on the same SAP HANA for large instance. What I'm trying to explain is by going into the object, my Amazon Direct Connect is a cloud service that make it easy to establish a dedicated network connection from your premises to AWS. The same thing front-end express does. It's a front-end it's a service on Azure Express route. Is used to provide secure high bandwidth connectivity to establish reliable connections between your network and the Microsoft Azure network. So this does the same job that Amazon Direct Connect does. Also, the same applies to SAP ASCS on VM, but on Amazon, it is called EC2. The virtual machine on Azure is called EC2 on Amazon. So, for example, what I'm trying to say is SAP EC2, EC2 is a subtype of VPC, VPC, I've forgotten the full meaning, but VPC is the virtual machine on Amazon, where VM is called is what it's called on Azure. So on SAP ASC2, EC2 on Amazon provides virtualized hosts where SAP application servers and data can be installed. The same thing that the VM does. So this requires high availability of central service and then true application service running on Azure VM in availability set offering a 99.5% uptime SLA. So that is the virtual machine difference between Azure and AWS. The same thing applies with Backend Express routes and Amazon Route 53. They do the same job on, they just have different name because AWS belongs to Amazon and Azure belongs to Microsoft. So coming down here on NFS storage, on Amazon is called EFS, Elastic File System, while on Azure it's called NFS Storage Primary. In this scenario, on Azure, NFS Storage does both the snapshot and also does the storing of the file. But in Amazon is a different case. In Amazon S3 stores the snapshots, while EBS does the storage of the file. So I'm going to talk more about this while I move further in my presentation. So going back to my slide, I have the model for my Azure Cloud concentration. And also for my AWS, then the contextual cloud orchestration modeling for both Azure and AWS. So I've been able to use my E+ to do to create the semantic relationship between the objects, because the lead ontology, like I've written down here, has identified and categorized most relevant object class type according to their context and exact connection to a specific cloud architecture layer. That is one of the power of object-oriented cloud model based on lead ontology. So I've been able to connect the relationship between them. I've been able to decompose and compose with using the cloud orchestration principle. So, like I said earlier, I've been able to categorize the cloud objects, cloud platform services on Azure and AWS, and I established the semantic relationship that has allowed an accurate description between various artifacts. I've been able to do this on my spreadsheets, which has formed my super map, and this has made me to capture the cloud concepts as objects, and I've been able to relate them within the context of the same artifacts. Thank you. I'm available for questioning now.
Okay, thank you very much, Iyiola, for that very informative presentation. Most appreciated.